Yeah. So the next section is polynomials. We're kind of turning the corner a little bit. As far as what we're doing is going to include a lot of exponent stuff, but it's stuff that kind of builds on each other. So if you really struggled with the exponent stuff and you're still not getting it, ask. Or as you get into this here, ask. This section has a decent amount of terms in it, and I'm typically not going to test you on a lot of the terms, but at the same time you should know what the things are, so as you refer to them, you kind of know what's going on. But okay, anyways, bicycles have two wheels because of well, that too, but the bi means two. So if you have this mono means one. Okay, good. So a monomial is going to be something that officially has one term. I'm going to put term in quotation marks. If you want like the Falkified version, the Falk version, a term is really just a clump. Because if you were to look at this, how many clumps are in that thing there? Three, right? Does that kind of make sense? If I were to ask you how many terms, you'd be like, what? But do you agree that's one thing? This is another, this is another? So each of those is going to be a term. Kind of each little clump is a term. So a monomial then could only have one of them. So maybe I should do so what counts as a term? You could have three things. You could have a number. So for example, if I were to say 4. 4 is a monomial. There's one clump of things there. You could have a variable such as x. X would be another monomial. You could combine those two things together if you wanted to and have like a 4x. 4x would also be a term, a single term. So the third option then over here on the right is going to be a product. And by product, we're talking adding, subtracting, multiplying, or dividing. Multiplying, yep. So M-U-L-T, I'm going to put in parentheses. Multiplication of numbers and variables. So I jumped the gun a little bit with my 4x. But 4x is a term because it's 4 times x. It's one kind of clump thing there. Or if you wanted to, you could get a little bit more exciting and say 14x to the 4th, y to the 7th. Yeah, look at that monomial.
That's a monomial.
One of us is more excited about that than others. But yeah, so because like this here we said was like kind of one clump of numbers, the clumps or the terms will always be separated by a plus or a minus. That if it's connected by multiplication, it's going to be one term. So a polynomial then, we said that mono means, oops, I'm on my eraser. So we said that mono means one. Poly, does anybody know what poly means? Many, nice. So a polynomial then is going to be, well, these two examples down here are polynomials. They're a bunch of monomials, many monomials put together. So it includes, first of all, just single monomials. If you wanted to, you could put a little arrow going to those. So each of those is a monomial, but technically it's also a polynomial. Just has to have at least one term. Or the second thing is going to be 2 plus, which is my short way of saying 2 or more monomials connected by plus or minus. So we have these two polynomials down below. 3x to the third is one monomial, and we have minus our second monomial plus our third monomial. Or this here is all one monomial plus another monomial makes this a polynomial. Okay for those? Cool. Then degree. Constants have degree 0. And a constant is really just a number. Do you agree? Maybe I don't want to go there yet. I'll just leave that out. So constants, if you have a number that has a degree of 0. A monomial, something like that, is, so if you just have a single thing like what we wrote above, the 4, the x, the 3xy, or whatever we had. So if one variable, if you only have one variable, the degree is going to be the exponent. So the degree equals the exponent. So if I were to have, for my example, I'm going to write a 5x. Do you agree that's a 5x to the first?
Yep.
So then this would have like a degree equals 1. I wouldn't do the change in red that I'm going to do to mine. But if I were to make this a 5x squared, then the degree is now going to be a degree 2. Is that fair? So, but I'll change mine back to what you have. So if you have more than one variable, so if you have like an x and a y, then what we have to do is we have to add together the exponents. So if 2 or more variables, if 2 plus variables, degree equals the sum of the exponents. So the example I wanted to do would be like 4x squared times y. So if we have 4x squared y. So that's still a monomial. It's just one clump. There's nothing separated by addition or subtraction. So if we wanted the degree there, the degree, nice, I heard it from somebody, 3. And the way you get that is it's an x squared, and it's a y to the first. If it's the first part, you don't have to write it in. So this 3 here comes from the 2 plus 1. So just adding those exponents. You okay for monomials?
Yep.
Polynomials is similar. A polynomial, maybe let's say this here. Just in this first part, what's the degree of that going to be?
4.
Degree is going to be 4, because I have an x to the first, a y to the third, 1 plus 3 is 4, right? This middle part here has a degree of 5, and the 7 has a degree of 0. Because you could look at this as though, do you agree it's 7x to the 0? Because x to the 0 is just going to be 1. There's kind of like 0 x's there. So you could look at that as though it's 7 times 1. The x to the 0 would be 1. I'll take that off just so it's not confusing later. So if you have a polynomial then, one of these like multiple monomials strung together, the plus or minus, the degree is going to be the degree of the largest monomial. Largest monomial. So we had 3 monomials in this polynomial. The largest degree is the 5. Yep. So this one here, the whole thing would have a degree equals 5. Maybe I shouldn't have put that arrow just going to this one, but the degree of the whole polynomial itself, that whole 4x y to the third minus 6x third y squared plus 7, is going to have a degree of 5.
All right, letter D, standard form. With this, terms or clumps are going to be written in a certain order, which makes it way easier down the road. So usually the terms or clumps are written from highest exponent to lowest exponent. And then you'll see here in the example, we have the 2x to the fourth. The x to the fourth comes before the minus 7x to the third, which comes before the plus 5x to the first. And we're really just looking at those exponents, the 4, the 3, the 1. And then the minus 8, if you have a constant, a number without an exponent, that will come here at the end. And also I should write this down. The numbers in front of variables are called coefficients. So the 2, the number in front of the first term, the number at the beginning of the polynomial, when it's written in standard form, is going to be called the leading coefficient. I'll say that's the number before the variable to the highest power. All right, letter E, special names. So we have special names for polynomials of certain sizes. So polynomial is made up of those different clumps or those different terms. If it has one term, it's called a monomial. And an example of a monomial would be something like 4x. It just has one clump or one term. Something with 2 terms is going to be called a binomial, like a bicycle has 2 wheels. So 2 binomial. And an example of a binomial could be 4x plus 5.
Three, our next one.
Trinomial.
Nice, trinomial, like a tricycle. And if we're going to have 3 parts, we'll have to at least have like an x squared in there. So maybe a 8x squared minus 7x plus 2. So you have 3 clumps that you can't combine together quite yet. And the last one, we just say 4 or more. So 4 plus, we call a
Polynomial.
Yep, polynomial. Although technically the ones above it are also polynomials. But if you have 4 or more, we don't start calling them like quadranomial or something, pentanomial, and they're just polynomials. So
Like the
hexanomial? I don't know. They just call them polynomials. So, all right, degrees then. For these, I'm only going to ask you to know the first few. But if we were to have a degree 0, do you remember what degree zeros look like?
numbers.
They're just a number. So we'll call that a constant. So if you have a number like 5, it's always 5, it's constant. So I'm going to put after that no variables. A little bit sloppy there. Or you could, if you wanted to, write the little hashtag for number, something like that. If we're to have a degree 1, if we were to have like 4x, or maybe a y equals 4x, if you were to graph that, what's it going to look like? A line. So we call this nice, linear. So line with an AR on the end. Arr! Pirates working on math. Okay, linear. So because the graph equals a line. And if we were to have 2, so if you wanted to say like a y equals 3x squared or something like that, or just even an x squared, you have to have a second power in there. Something formula, famous guy, x equals negative b plus or minus. Haven't learned it. I should know that. I'm your math teacher. Okay, quadratic. I cut you off. So quadratic. We learned the quadratic formula. I guess it's not a guy. Okay, degree 3, so like an x to the 3rd power is, well, this would be x squared. If you had an x to the 3rd, you'd call that x cubed. Nice, so this is going to be a cubic. So if you had like a y equals x to the 3rd, or y equals 2x to the 3rd, that'd be a cubic. And then they keep going like quartic, quintic, and then they just start doing 6th degree, 7th degree, 8th degree, but you don't need to know the other names. We'll skip those. Ready to hit page 3? No. We're almost done. This is kind of sad. When we're having all this fun. Classifying polynomials by degree and term.
That one's a
So what's the degree for this thing here? Nice. So we have degree equals 1, because we have an x to the 1st. And we could say that it's 2 terms, right? So terms equals 2. So if we want to combine those together, when something has a degree of 1, we call it, nice, so this here is a linear binomial, yep. Linear because it's degree 1, trinomial because it has 2 terms. Our next one is going to be degree, you're ahead of me, terms 3. Oh, degree is not 3, degree is 2. Got a little excited? I was trying to keep up with you guys that were saying trinomial.
No, you said trinomial up there, but
Yeah.
no binomial.
Okay.
That's all.
So this one here, if it's degree 2, we call it a quadratic. In terms 3, it's a quadratic trinomial. And the last one, degree 7. And the terms would be 4, right? We still count this because pi is just a number. So degree 7, terms 4. So we would just call it a 7th degree polynomial. Yep. 7th degree polynomial. How are we? Good?
Isn't the second one that?
So when we start doing this, a lot of times they'll do like the height of an object because that's an equation that'll give you this variable squared in there. So what we're saying is if you take and throw a ball straight up at 50 miles an hour, its height is given by this equation here. And its height is actually going to be the height in feet. So if we wanted to find the height of the ball after 2 seconds, where do we put 2 in this thing here? Yep, nice. If it's 2 seconds, do you agree? This here tells us that t equals 2, the time is 2. So in other words, we'd have negative 16 times 2 squared plus 73 times 2 plus 3. And you'll get some people that go through and they take this in all little parts and punch something in the calculator, hit equals, punch something else in, hit equals, punch something else in. But you could take and just punch this whole thing in one time, and your calculator will just spit out the final answer for you. If you're going to do it individually, like each individual clump, the most common mistake is people will multiply these two together and say, oh, that's negative 32 squared. But what comes first, multiplication or exponents? Exponents. So you have to first do the 2 squared and then do negative 16 times 4 plus 73 times 2 and so on. But if you punch it all in, you should get 85, which would end up being 85 feet, even though you don't really have a way to know that from what I wrote in the problem. But if you try punching that and you get something different than 85, let me know. Good? Nice. So this section kind of lays the groundwork for where we do some adding and subtracting in the next section, and some multiplying, and so
Should we mess that or what?
it gets even more fun.